So this is going to be the review for test 4. So the polygons are similar. Find the value of the variables. Okay, so they're similar, so that means we have to compare certain things to certain things. Because whenever we're talking about similar things, we're going to have proportions that are going to be comparable. So A is next to this double, so if we have to match it, that means 12 is going to be its match. So I'm going to do A over 12 is equal to, now I need a number, so let's do 9 over 15, because those are comparable to each other. And now we have to solve. So A times 15, drop our equal sign, and 12 times 9 is 108, divide by 15. So we have A equaling 7.2. Now we have to find B, so we have to do some more comparisons. So we can use that 9 over 12 again is equal to, B is comparable to 10. So since I used 9, which is from this triangle, I have to have B on top, so it's the same triangle. And it is comparable, we said, to 10. So 9 times 10 is 90. We drop our equal sign, 12 times B. So to get B by itself, we take 90 divided by 12. So B is 7.5. Okay, we need to find all of the missing angles. So, I'm going to zoom in here. Oops. Okay, so let's see what we can do. So we have parallel lines, so these ones we're going to be using alternate interior and stuff like that. So, let's see. So it looks like if I use these two parallel lines here and this transversal, I can find A should be 72 because alternate interior angles are congruent, so the measure of angle A is 72 degrees. We can find out, since these have that congruent sign, that means it should be the same. So that's 72, that's 72. This creates 180 degree angle, so we could find B by adding 72s together, so 144, and subtracting that from 180, so B is 36 degrees. Don't forget your degree sign. C, this creates a straight line, so I could take 180 minus 36 to get that. So 180 minus 36, so C should equal 144. This creates a straight line, and the B is a vertical angle, so we can say that this is 36 as well. We can find K because 36 plus 90, that square means 90. All triangles should add to be 180, so we could subtract whatever that is from 180. So 90 plus 36 is 126. 180 minus 126 is 54. So we know K is 54 degrees. Alright, if this angle right here, A, is 72, we have these two sides being the same, which means these two angles should be the same. So if I take 180 minus 72, we have 108 degrees left. If those two angles are the same, if I just cut 108 in half, it should give me the measure of each of these angles, which is 54. This creates a straight line, so I can take 180 minus 54 to get the measure of angle M to be 126. These two are 72, so whatever's left from 180 should be D. So 72, so 180 minus 144, the measure of angle D is 36 degrees. This creates a straight line, so 180 minus 36. So the measure of angle E is 144 degrees. These are corresponding angles. Corresponding angles should always be the same. So measure of angle H is 144 as well. So J and B are also corresponding. So we could say the measure of angle J is whatever B was, so 36. So all we have left to find is J and G. Okay, so 144 here. These sides are the same, so that means the angle should also be the same. So I could take 180 minus 144, cut it in half to find those angles. So the measure of angle F right now is 18 degrees. So that's 18. that's 18. So this creates a straight line, so 180 minus 18. So the measure of angle F should be 162 degrees, which I think is all of the angles that I see. Oh, I mean, the measure of angle G is 162. Sorry. Okay, find X and Y. So if this is 120, if these sides are the same, it means these angles should also be the same because it's an isosceles triangle. So I'm going to take 180 minus 120 to see what I have left that I can use. I have 60. If I cut 60 in half, I should get these angles here, which are 30. So the measure of angle Y is 30 degrees. So if these are the same, it means these are the same. So that means these are 45 degrees. So that adds to be 90. So 180 minus 90, and it should get me what X is. So the measure of angle X is 90 degrees. Alright, so this is 90 degrees here. So if these are the same, that means these are the same because they're isosceles. So if I take 180 minus 90, I have 90 left over to split between those two, so I cut it in half. So the measure of angle N is 45 degrees. This angle is the same as this angle over here, so that's 45. So if these are the same, it means these angles are the same. So I'm going to take 180 minus 45, so I have 135 left to share between these two angles here. So we're going to cut it in half. So the measure of angle M should be 67.5 degrees. Alright, this is an equilateral triangle, so if it's equilateral, it's also equal angular, so that means all of these angles should equal. If all angles in a triangle add to be 180, and it's an equal angular triangle, that means each of the angles are 60 degrees. So to find out what X is, I'm just going to take 4X and set it equal to 60. 60 divided by 4 is 15. So X then would be 15. The ratio of the length to width of a rectangle, so it's written respectively, so this is the length, this is the width, and the perimeter is 60 inches. Okay, so I'm going to take 3x plus 5x equals 60, so 8x equals 60, divide by 8, so x equals 7.5. What is the width of the rectangle? Well, the width is the 3, so I'm just going to take 3 times 7.5 to get 22.5 inches. The measures of the angles of a triangle are an extended ratio of 6, 2, and 3. What is the measure of the largest angle? So 6x plus 2x plus 3x. All angles in a triangle should add to be 180 degrees, and we're talking about angles. So that's why we said equal to 180. So we have 6x plus 2x is 8x, plus 3x is 11x. 180 divided by 11 is 16.4. But I want to know what the largest one is. Well, 6 is my largest angle ratio. So I'm going to plug that in for this. So then my largest is 98.2 degrees. We're talking about the largest angle, so make sure you measure it with the degree sign. Okay, we are solving. So these are the ones that to get them to be similar here, we're solving for x, so we're going to make a ratio. So I'm going to do 3 over what's comparison to it, so 6, and set it equal to 9, and what's comparison to it, so x. Okay, because we learned the side splitter theorem, we learned angle bisector theorem, but when we have two separate objects like that, to solve for x and y, we need to set them comparison to each other. So kind of like seeing if they're similar. So now we're going to cross multiply, so 3 times x, drop our equal sign, 9 times 6, divide by 3, so x equals 18. We're going to do the same thing with the other one. So I'm going to take x plus 4, and it's similar to 8, and I'm going to set it equal to numbers. Because if I do y or x here, I'm going to get really confused because there's going to be tons of variables in it. So let's do 7. So we did x plus 4 on top, so this triangle. So I have to do this triangle again. So 7 over 3.5 is comparison to it. So now we need to cross multiply. Oopsies. 7 times 8. 56, drop our equal sign, 3.5 times all of x plus 4, because now we have to distribute. So now I have 56 equals 3.5x plus 3.5 times 4 is 14. Now we need to solve it, so subtract 14. So 42 equals 3.5x. Divide by 3.5. So now I have x equaling 12, so that means this is 12. If I plug 12 in for x here, 12 plus 4, that's 16. So now we need to solve for y. So let's do 7 over 3.5 again, and set it equal to 3y, because we did 7 from that triangle first, over what, well, we plugged x in for 12, so now we have a number here, so it's not two variables. So cross multiply, 7 times 12. We have 84. Oops. 3.5 times 3y is 10.5y. We dropped our equal sign. Divide by 10.5. So we have y equaling 8. Sorry, I'm trying to figure. There, so we have y and x now. A company makes a rug. The smallest rug is 2 feet by 3 feet. Their largest rug is a similar rectangle. If one side of their largest rug is 18 feet, what are the possible dimensions of their largest rug? Okay, so I'm going to say, says one side is 18, so it could be this side and it could be this side. We're not sure. So let's make it this side first and figure out what it is. So we're going to compare. So I have 3 over 18 compares to it equals 2, because I'm going from the same rectangle again first, over x compares to it. So if we cross multiply, we'll get 3x equals 36 divided by 3. So x would equal 12 feet. Or, now if we flip-flop these, it's going to flip my proportion here. Because it doesn't say if the longest side is 18. If the longest side is 18, that means 18 would have to go down here, because it would have to be comparison to the longest side of the other one. So let's make 18 over here. Redo our proportion. So right now one possible option is an 18 by 12. So now my next one, if I do 3 over x's comparison to it and 2 over 18, we'll have 18 times 3, 54, drop our equal sign, 2 times x, divide by 2. So now x is equal to 27 feet. So this situation would be 8 by 27 feet. Okay, but it doesn't say what side has the 18 feet. So those are your two possible dimensions that you could have for that rug. Alright, so this is like the side splitter theorem or the corollary. Okay, so these ones you're comparing the sides. So I'm going to take the side over the side, so 12 over 3, set it equal to, if I use 12 from this triangle here, I need to use this from this triangle, so 2x minus 3 over the same side, so x minus 5. We're going to cross multiply to get 12 times x minus 5. We drop our equal sign. 3 times 2x minus 3. Now I got to distribute, so 12x. 12 times 5 is 60. 3 times 2 is 6x. 3 times negative 3 is negative 9. Let's add 60. Minus 6x. So x equals 8.5. Okay, these are the angle bisector ones this time. So again, you're going to set the sides comparable to each other. So x and 6. So I'm going to take x over 6 because they're from the same triangle. We used x on this side, so comparison to it would be 24 over what we have left is 8. So I'm going to get 8x equals, drop our equal sign, so 6 times 24, 144. We're going to divide by 8. So x equals 18. Okay, this next one is very similar to it. Okay, so let's look at this little triangle first. So I'm going to get 10, so 10 is my one side, x is my other side, is equal to 10 is comparison to 15, because if you flipped your triangle up, this corner is the same as this corner. So I'm going to take 15 first, and then I don't know what this length is because this entire length represents 18. But if I would know what x is, I would subtract it from 18 to get that little length. So I'm just going to put 18 minus x here. I'm going to cross multiply, so I'm going to get 10 times 18 minus x, drop my equal sign, 15x. So I'm going to distribute that to get 180 minus 10x equals 15x, add 10x. So 180 equals 25x. So x would equal 7.2. So just be careful, if 18 represents this whole thing, you're going to have to subtract x off of it because we don't know what that length is.